Human activity has a significant impact on the rock cycle, and it's important to understand these impacts to develop sustainable practices for managing them. One major example of human impact on the rock cycle is mining and quarrying. These activities involve extracting rocks and minerals from the Earth's surface, which can have a significant impact on the environment and geological processes. Mining and quarrying can cause changes to the landscape and affect the local ecology. It can also lead to the destruction of important geological features, such as rock formations and fossils. In addition, mining and quarrying can alter the chemical composition of the surrounding soil and water, which can have negative impacts on the environment and human health. In this section, we'll explore the journey that rocks take through geological time. We'll also learn about plate tectonics, which is a key driver of the rock cycle. Finally, we'll discuss the geological timescale, which helps us understand the vast periods of time involved in the formation and transformation of rocks. So, let's start with plate tectonics. This theory explains how the Earth's lithosphere, or the outermost layer of the planet, is divided into several large plates that move around on the underlying asthenosphere. These plates interact with each other in various ways, such as by colliding, diverging, or sliding past each other. These movements create the conditions necessary for the formation and transformation of rocks, as we'll see in the next section. But first, let's talk about some examples of rocks at different stages of the rock cycle. For instance, magma, which is molten rock below the Earth's surface, can cool and solidify to form igneous rocks like granite or basalt. These rocks can then be uplifted and exposed to erosion, leading to the formation of sedimentary rocks like sandstone or limestone. Over time, these sedimentary rocks can be subjected to heat and pressure, causing them to transform into metamorphic rocks like marble or slate. Finally, if these rocks are subjected to enough heat and pressure, they can even melt and become magma again, completing the cycle. All of these processes occur over millions or even billions of years, which brings us to the geological timescale. This scale divides Earth's history into eons, eras, periods, epochs, and ages, each with its own distinct events and characteristics. For instance, the Precambrian Eon, which spans from the formation of the Earth to about 541 million years ago, is known for the formation of the planet's first continents, the emergence of life, and the development of photosynthesis. Understanding this scale is crucial to comprehending the long-term processes that shape our planet's geology. Rocks play an important role in our daily lives and have various uses in different industries. Igneous rocks, for example, are commonly used in construction as they are strong and durable. Granite, which is a type of igneous rock, is often used for countertops, flooring, and monuments. Basalt, another type of igneous rock, is often used for road construction and as a base material for building foundations. Sedimentary rocks are also important as they contain fossil fuels such as coal, oil, and natural gas. These fuels are used to generate electricity and power transportation. Sedimentary rocks like limestone are also used as construction materials and in the production of cement. Metamorphic rocks are valuable for their decorative qualities and are often used in building and sculpture. Marble, for example, is a type of metamorphic rock that has been used for centuries as a material for buildings, monuments, and statues. Slate, another metamorphic rock, is often used as roofing material and in interior design. It's important to note that the extraction and use of rocks can have significant impacts on the environment. Mining, quarrying, and other activities can lead to habitat destruction, pollution, and other negative effects. As such, it's important to use rocks in a sustainable manner and consider the environmental impact of their use. Overview of famous rock formations. Famous rock formations provide a glimpse into geological history and offer insight into the processes that have shaped our planet. In this section, we will take a closer look at some of the world's most famous rock formations, including Uluru, Ayers Rock, and the Grand Canyon. We will explore their unique geological characteristics and how they were formed over millions of years. By understanding these formations, we can gain a better understanding of the geological history of our planet and the forces that continue to shape it. Explanation of their formation and geological significance. Uluru, Ayers Rock. A massive sandstone formation that rises 348 meters above the surrounding landscape, Uluru was formed over 550 million years ago from deposits of sediment that have since been uplifted, eroded, and exposed. It is an important site for Aboriginal culture and is considered a sacred place. Grand Canyon. One of the most famous and iconic geological features in the world, the Grand Canyon is a vast canyon system that has been carved by the Colorado River over millions of years. The exposed rock layers in the canyon provide a record of Earth's geological history spanning over 2 billion years. Giant's Causeway. A geological wonder located on the coast of Northern Ireland, the Giant's Causeway is a series of hexagonal basalt columns that were formed from a volcanic eruption approximately 60 million years ago. Stonehenge. A prehistoric monument located in Wiltshire, England, Stonehenge is a ring of standing stones that were erected over 4,000 years ago. The origin and purpose of the monument is still debated, but it is believed to have been a site of religious significance and astronomical observation. C. Importance of these formations in understanding geological history. These formations provide a tangible record of Earth's geological history and the processes that have shaped the planet over millions of years. They are also important cultural and historical sites that provide insight into the beliefs and practices of ancient civilizations. Studying these formations can help us better understand the natural processes that drive geological events and inform our management and conservation of geological resources. The field of geology and rock science is constantly evolving with new discoveries and breakthroughs. Recent studies have shed light on previously unknown aspects of the rock cycle and geological history. These discoveries have helped us better understand the Earth's past and how it has evolved over time. For example, new techniques have allowed scientists to study the composition of rocks in more detail, leading to a greater understanding of how rocks are formed and transformed. Looking towards the future, there is a lot of potential for further research in rock science to have a significant impact on society. For instance, the study of rocks and minerals can provide valuable insights into natural resources and their availability. Additionally, new technologies and techniques can help us better understand and predict natural disasters, such as earthquakes and volcanic eruptions, which can save countless lives. In this section, we're going to talk about the tools that are used in rock science. There are a variety of tools that geologists use to study rocks and understand geological processes. Some of the tools that are commonly used include microscopes, geologic maps, GPS systems, and seismic sensors. Microscopes are used to study the mineral composition of rocks, while geologic maps are used to identify rock formations and geological structures. GPS systems are used to track the movement of tectonic plates, and seismic sensors are used to measure earthquake activity. Each of these tools plays an important role in helping geologists understand the rock cycle and the history of the Earth's geology. By using the right tools, geologists can collect accurate and reliable data that helps them make important discoveries about the Earth's past, present, and future. It's important for geologists to use the right tools for their research, as this ensures that their findings are accurate and efficient. Overall, the tools used in rock science are crucial in helping us understand the complex processes that shape the Earth. As technology continues to advance, we can expect to see new tools and techniques that will help us gain even more insight into the world around us. Rocks are not only fascinating to study, but they also play a crucial role in our daily lives. In this section, we'll take a look at how different types of rocks are used in our everyday life. For example, igneous rocks like granite and basalt are commonly used as building materials due to their durability and strength. Sedimentary rocks like sandstone and limestone are also used as construction materials, but they are also important sources of fossil fuels like coal and oil. Metamorphic rocks like marble and slate have many decorative and practical uses, such as flooring, countertops, and sculptures. Understanding the properties of rocks is important for their practical use, as different types of rocks have different strengths and weaknesses that must be taken into account. It's also important to consider the environmental impact of using rocks. The extraction and use of rocks can have a significant impact on the environment, from the destruction of natural habitats to the release of pollutants into the air and water. Sustainable practices in the use of rocks are therefore crucial to minimize these impacts and ensure their availability for future generations.